Let's talk spanning tree part 2. Alright, so in my last spanning tree video, I talked about what spanning tree was and how it helps your switch networks by blocking any looped or broadcast storm type of traffic. So now let's dive a little bit deeper into spanning tree. Hi, I'm Rich. Welcome to the Rich Tech Guide channel, and in this video we're going to go a little bit deeper in and talk about some of the things we can do with spanning tree to make it more efficient and to help your layer 2 switch networks converge a little bit faster. So first, let's go over spanning tree. Now, I'll do a quick review here, and I actually encourage you first of all to go check out the part 1. I've got it down below in the description where you can go review that video if you haven't seen it. But let's go over to a quick review of spanning tree, which is defined by the IEEE protocol and the IEEE standards 802.1d. Now, when spanning tree is operating, there are 4 interface modes for your switch ports, and it is blocking, learning, it's blocking, listening, learning, and forwarding. So in the blocking state, the switch interface is blocking all traffic. Now it will receive bpdu's, bridge protocol data units, from other switches, but it will not send traffic, it will not send its own traffic, or its own bpdu's. Now, with the learning state, or actually the listening state would be the second state. In the listening state, it is starting to listen and do some sending and receiving of bpdu traffic, and it's gathering that data. And then from there it will go into the learning state. Now in the learning state, it will actually not only be handling the bpdu traffic, but it will also be watching incoming data traffic. It's not sending data traffic out, it's not forwarding data traffic in the learning state, but it is learning from the traffic. It's looking at the MAC addresses coming in and making adjustments to its MAC address table and setting up the process to go to the next level. And finally, you have the forwarding state. So in the forwarding state, what happens is the spanning tree protocol has run its course, and it is determined that the interface is either the best path to route, or from that interface there isn't another path, or there isn't a suboptimal path to route. So when it makes that determination, it will put the interface into forwarding state, and it will begin sending and receiving data traffic, and will be operating as a regular switched port. Now, if the switch determines that after running its spanning tree process that interface has a suboptimal path to route, and back to the root switch, then what it will do is it will actually send it all the way back to state 1, the blocking state. The other thing I want to touch on is there are 2 other states that a switched interface can be in, which are often associated in spanning tree but are not actually specific to spanning tree. Now those interfaces are a administratively down state, where the network administrator has issued the shutdown command on the interface and actually brought it down through the configuration. And then there is a broken or error disabled state. And this state happens if there is a configuration issue or something is wrong with the traffic either being received or sent on that interface, and the switch has decided that the best course of action is to bring down the interface to prevent other issues from going on. So if you have a state that is in broken state or error disabled state, then you're going to need to go do some troubleshooting mechanisms on that interface to figure out what's going on. Going into the process for spanning tree, that whole convergence state from the blocking state all the way through the listening, the learning, and then to the forwarding state, that could take 50 seconds to complete. Now, depending on what you're doing on your network, that may be okay, that may be acceptable. On the other hand, that may not be acceptable. So the situation that I even ran into that just comes top of mind for me is this was many years ago. I was trying to get a server, or actually a few servers, to boot from iSCSI across the network. And Spanning Tree could not bring the interfaces up fast enough for the iSCSI boot protocols to connect to the storage and get the data that they needed to boot, causing the servers to fail while they were booting. Now, 50 seconds is a really long time, and iSCSI doesn't have that time. So there's a method that I'm going to address later that can really get into that. But first, I'm going to also talk about another spanning tree protocol that can speed up that convergence time. An alternative spanning tree protocol that exists is called rapid spanning tree. Now, rapid spanning tree was created as a way to bring faster convergence times. And in that, the port states are reduced down to 3 different port states. The first one is discarding, and the second one is learning, and then the last one is forwarding. So in the discarding state, that is like the blocking state on rapid spanning or on regular legacy spanning tree. So discarding, blocking, those are essentially the same. Rapid spanning tree's learning state essentially combines the listening and the learning states from legacy spanning tree. And in the learning state of rapid spanning tree, it is learning MAC addresses and updating its MAC address table to figure out where to send traffic. And then lastly, of course, you have the forwarding state. And the forwarding state is just like the forwarding state in the legacy spanning tree. So when you have rapid spanning tree running, your convergence time actually gets cut almost in half. It runs about 30 seconds as opposed to the 50 seconds. So that's a much faster convergence time, so that may help out with some processes running on your network. On the other hand, if we look at the iSCSI example that I brought up earlier, where I'm trying to boot off of iSCSI from a server, even rapid spanning tree in that particular instance didn't bring the interfaces on fast enough. So there's another way we can get around that. And that's using something called port fast. Now on a switch, you can set port fast to an interface, and it's simply you get onto that interface and it's spanning tree port fast, and what that does is that tells the switch that you know as the administrator that that interface is not connected to another switch. It is connected to an end device. So you are basically telling the switch, don't worry about spanning tree on this particular interface, just bring it up. And that is effectively what you have to do when you're doing something like a server booting from iSCSI off your network. You need it up immediately. So now there are 2 ways you can deploy port fast. There is the standard just port fast, and then there's another one called port fast trunk. This is one that you need to be careful with, but you also need to be aware of it. So let's say you've got a server that is running a hypervisor and you're running multiple VLANs off of that server, and you need to essentially do a trunk line to the network interface on the server. In that case, you're going to do spanning tree port fast. And when you do that, the switch will give you a warning. It's like, hey, make absolutely certain you're not doing this to another switch, or the spanning tree port fast trunk to another switch, because if you do, you are creating the situation for a broadcast storm and for loop traffic to shut down your network. Now, there is also a little insurance thing you can do when you are running port fast on an interface, and that is called bpdu guard, and you effectively deploy that using spanning tree bpdu guard. And what bpdu guard does is you are basically telling the switch, hey, I know right now there's not a switch on the other end of that, but just in case, maybe in the future some junior network admin decides, hey, I'm going to switch out the interface here and hook up a switch to this port. So you're setting up this insurance just in case any BPDUs happen to come in on that interface. Keep an eye out for them. And so when you activate BPDU guard, when the ports or when the BPDUs come in, say some point in the future that a switch did get hooked up to that interface, it will shut the interface down. It will put it into the broken error disabled state and force you to troubleshoot, and that way you can prevent that loop from happening. Now before I move on to the next mode of spanning tree to talk about here, I do want to bring up one other thing, and that is what happens when you have a switch running legacy spanning tree and you connect it to a switch running rapid spanning tree. And what happens in this case is the switch running rapid spanning tree is the rapid spanning tree protocol running on it is backwards compatible. So it will identify that, oh yeah, this other switch is not running the same level. It's not running 802.1w. It's using the legacy spanning tree mode. So I'm going to just go ahead and go back to legacy spanning tree and work with that switch. Now moving on to the next mode of spanning tree, and this is the last one I'm going to talk about, it's called MST, or multiple spanning tree. This is defined by the IEEE standards 802.1s. And in multiple spanning tree, the purpose here is for really large deployment networks where you have a lot of VLANs. Because the way spanning tree has evolved is originally spanning tree covered everything, didn't care about VLANs, but then it evolved to be per VLAN spanning tree. So every VLAN is a spanning tree instance which is using processor cycles on your switch. MST is a way of reducing those processor cycles and increasing convergence time, or decreasing convergence time actually. Now what MST does is you set your switches into MST mode and then you create MST instances. In the MST instances, you will define which VLANs exist within the instances. You will have a default instance of 0 that when you first create it, it will have all the VLANs in it. And then you can move VLANs out of that into other MST instances. The other thing that this allows you to do is to create load balancing. You can use your route prioritization of your switches to set up different route switches in your MST configuration, and that way you can have a batch of VLANs using one route on your network, and then you can have your other VLANs going on a different path through your switch network. So what MST really does is it brings down processor cycles, saves that for actual usage and handling your data traffic, and also enables load balancing. When you have an MST configuration connecting to a legacy RSTP or STP network, it is backwards compatible. It will work with the other interfaces in a similar way that when you have RSTP connecting to STP. What you do need to be aware of in those instances with MST is you either have to define MST or one of the switches in your MST domain to be the root, or you have to utilize your root metrics to set one of your RSTP or STP switches as a root switch. We're going to go in and we're going to take a look at some of the configurations in my lab environment that I've got set up here. Same lab environment as I used in my previous spanning tree video, but let's go in there. We'll convert it to RSTP and then we'll convert it to MSTP or MST in order to show what's going on. Okay, so I'm on the first switch, and the first thing we're going to do is we're going to take a look at what the switch looks like versus normal 802.1d spanning tree versus rapid spanning tree 802.1w. So I'm going to do a show spanning tree, and I'm going to do this check on, I've got VLAN 200. So right here, what we can see is it says Spanning Tree Enabled Protocol IEEE. This is referring to the legacy Spanning Tree Protocol. Now, what I'm going to do at this point is I'm going to change it to be Rapid Spanning Tree. So in doing so, I'm going to do a Spanning Tree mode, and it's Rapid PVST, per VLAN Spanning Tree. All right, we're going to exit out, and then we're going to do another show Spanning Tree on VLAN 200. Now, right now it's showing all my interfaces are blocked because it's doing its reconvergence thing. Now, the other thing you notice is up at the top here, it says the Spanning Tree Enabled Protocol is RSTP, Rapid Spanning Tree Protocol, not what it said before with the IEEE. I'm going to run that again. Now my interfaces are up. I am the root switch here, and it is showing I've got all my interfaces are forwarding status, but because this is the only switch on my network running Rapid Spanning Tree, it's showing that the peer switches are running STP, Spanning Tree Protocol. So what's essentially happening here is it's negotiating with the other switches. The other switches are saying, hey, I'm running 802.1d Spanning Tree, and even though this one is running Rapid Spanning Tree, it's going to say, okay, I'm going to go backwards compatible and work with you there. So what I'm going to do is I'm going to hop onto another switch, and I'm going to set that to Rapid Spanning Tree as well. Okay, so on this one, again, we'll do a show Spanning Tree VLAN 200. Okay, it's showing IEEE, and on the port channel 1 interface, back to the root switch, it's showing everything's fine. It doesn't even recognize that the other switch is running a different Spanning Tree protocol. But let's convert this one now over to Rapid Spanning Tree. So with that, I am going to go to Input, Spanning Tree Mode, Rapid per VLAN Spanning Tree. And we're going to run this. Now, it's already come up and reached convergence with the other switch that's running Rapid Spanning Tree. Much faster time, however, it's still doing its negotiating and reconvergence. Again, Spanning Tree Enabled Protocol, Rapid Spanning Tree, RSTP. If I run this again, oh look, now they're in the learning stage, and it's recognizing that on these other two switches that it's connected to, they're running Spanning Tree. So we got to work through the process. As was mentioned, it's 50 seconds for legacy Spanning Tree to reach convergence. And now here we are at the forwarding state. So again, I can just continue on down through the network. And continue to convert these switches over to Rapid Spanning Tree. So I'm just going to quickly do that. Okay. Now this has very quickly reached convergence because the two switches it's connected to are in Rapid Spanning Tree mode already, and it has identified out of its gig 00 interface, it is connected to the root switch, or that is the shortest path to root. So that is getting a root status and forwarding over to the other switch that it is connected to. It's saying that is a suboptimal path, but there is a path to root, so it's blocking it. And on the final switch, And again, it has quickly reached convergence. So that was a very simple and easy process to convert the switches over to rapid spanning tree protocol. Okay, so now we're going to convert these switches over to MST, multiple spanning tree. So in order to do that, we are going to change the mode once again. And if you look at it, we've got MST as the spanning tree mode we can use. So now I'm on switch 1. I'm also going to convert that over to spanning tree MST. Okay. And on switch 2, and on switch 3. In order to configure MST, or multiple spanning tree, I have to create instances, and then I have to put VLANs into those instances which MST is going to manage. So in order to create the instances, I'm going to do spanning tree MST, or spanning MST configuration. Now I'm going to create, okay, instance 0 already exists, and I'm going to make sure that I've got a particular VLAN in there, VLAN 100. Now I'm going to do instance 1, and I'm going to apply a few other VLANs in here. I've got 200, 250, and 300. And then I'm going to create another instance, instance 2, where I have my native VLAN for trunking. So I'm going to throw that into that. So that's VLAN 555. That's going to go sit there. Now, what I can actually do inside of this is I can do a show pending, and that basically shows me what my mapped instances look like. However, this is still pending. This has not been applied yet. In order for me to apply, I have to exit the config mode. There are two ways to exit the MST config mode, and this is kind of a catch on Cisco switches here, is instead of just typing in exit to get out of it, well, you would do that if you want to save the configuration you have made. If you don't want to save that configuration, if somehow you've messed up, you want to just abort and then start over, then you would actually type in abort instead of exit. But because I want to save it, I am going to exit out. So now I'm going to verify everything that I've got for MST and for spanning tree. What I have here is on instance 0, which is represented by MST0. It says spanning tree enable protocol MST. Right now things are learning. There's some forwarding. There's actually a port being blocked at this time. And then I'm going to go over here. We've got MST1. So where at this point it's saying this one is the root switch. So again, everything is in forwarding state. We're fine here. And then we have MST2, so instance 2. So now I've got it configured for spanning tree in MST mode. So that's the end of our deeper dive into spanning tree, covering rapid spanning tree and multiple spanning tree. In the lab, the one thing I wasn't able to cover really was the port fast or the bpdu guard commands, but just know that they are out there. If you like this content, please hit like, hit the subscribe button for more content as I put it out, and please leave a comment if there's anything you would like me to discuss or talk about, be it on networking or on IT industry in general. Be happy to hear your feedback on that. So with that, thank you very much.